So what the heck is going on now? Recently I'm doing 3D printing related experiments and hacking Xbox, the gaming console, for high resolution 3D printing. Here you can see a graph that this is the commercial 3D printers, but none of them can print a nano resolution and the centimeter cubic volume. So, but unfortunately, we need to print this kind of microstructure for drug delivery. As you can see, this expensive one can print the large volume, but it cannot print the small structure. On the left-hand side, you can see the crazy expensive one can print a small structure, but it takes forever to print this large volume. So that's why we decided maybe you can make our own 3D printer. So we have a project that we just use the optical pickup unit from the Xbox. So this is Xbox, and we open it, and this is the OPU, optical pickup unit, and if you buy on the market, it's less than $5 US. And its resolution is like a research grade microscope. It can focus laser light in nanoscale. And then we use this OPU to build a 3D printer. So this is how we print. We just move the head around, and we can have a solid structure cured. And then we publish the paper to show this printer. And you can see this OPU underneath, and we laser light shines through the photopolymer, and we print a solid structure on the substrate. So this is the system photo. Actually, our optical unit is very small. It's much smaller than the XYZ stages. And on the right-hand side, you can see we can achieve a nanoscale resolution, and we can have a microstructure, several hundred micron, and we can have a large volume of printing. That fits our need for our research. So when this paper published, we found out that in the 3D printing field kind of went viral, that our news. So they were surprised that the gaming console component can do high resolution 3D printing. Especially high resolution 3D printing. Right now, the printer, they are so expensive that not many people can afford. And then this system, when we have a team and become a pre-startup company. So we are not only print like a drug delivery device, we'll also print the Eiffel Tower. It's so small that you cannot see with the normal photo captured by the mobile phone. So this is the zoom in, and this is the SEM photo. So we can get high resolution, and we can print much larger area. Okay, so here is another hack that I'm working on now. I think I skipped this because previous one we're tackling the price, and this one we're tackling the throughput of printing. When you print high resolution and your throughput is really low. So what about if we print high resolution and we have a higher throughput than the traditional system? And then again, optical drive, the Blu-ray drive can spin like 10,000 RPM, and the linear velocity can achieve 61 meter per second. It's super fast. And the laser spot of the Blu-ray head, you can see is around 300 nanometer. So we just try to print, develop a 3D printer. So we call the Blu-ray based high throughput 3D printer, Bright 3D. So firstly, we have a normal Blu-ray drive, and you see the OPU underneath the disk, and we have spindle motor here. And we can spin coat photopolymer on the disk. Then we have another OPU on top, and we are 3D printing this photopolymer. And we have a control system. So when the disk is rotating and the laser light focus on the photopolymer, and then we can have a 3D structure cured. So this is our recent prototype. So this is the top OPU and bottom OPU is underneath the disk. So this is the spin coating process. So we can have a nanoscale layer on the disk. And this is the printing process. So you can see the disk is wobbling like crazy, up and down. But how can we maintain the laser spot on the disk for 3D printing? Actually, we implement a lower OPU to read the wobbling and to feed the signal to top OPU. And then we can focus the laser precisely on the disk. So here you can see the 2D printing result. You cannot see on the left, but if we zoom in, you can see some structures we cured. So this on the left hand side, this is the pattern we plan. On the right hand side, this is the pattern we print. Actually, we can print tens of micrometer features on the disk, but this is only one layer. And later, we spin coat 3 times and we print 3 kind of patterns. So you can see the first layer, the pattern is bigger, and the second is smaller, and the third layer is even smaller. So we try to see if we can print 3D structure. And we did it. This is you can see we have some kind of donut shape structure. Actually, there are 3 layers combined together. And this is a zoom in of the structure. So this is kind of pyramid. We have 3 layers, and the first and second and third layer. So you see this is kind of not so precise, right? But I need to remind you that this is 1 million micron, the linear speed. And this, the uncertainty of printing is about 6 micron.